Hello friends, today I will discuss the starting methods for the synchronous motor. Synchronous motor do not have the self-starting capacity. So to start the synchronous motor, it needs different methods. So one is starting as an induction motor, the other method is starting with wound motor, starting as a wound motor. So let me discuss first this, that is starting with wound motor or starting as a wound motor. Starting as a wound motor means here the synchronous motor stator is a star connected. It's assumed like this, and this stator is connected to the three-phase AC supply. Similarly, its rotor is a star connected rotor, and that is slip ring rotor, and these ends of the rotor windings are connected to the slip rings, and slip rings are connected to the brushes, and brushes are connected to the uh, tripole double throw switch. That is, one time it can be connected to one side, similarly the other side other side elements. So when this switch is connected to the left means DC supply will be connected, that is finally we connect like that. So if this switch is connected to the right means it will be connected to the uh, three-phase rheostat. This is also called starting resistance, and this is the shaft of the rotor. So in this method, initially this switch, that is slip rings, are connected to the three-phase resistance or three-phase rheostat, that is also called starting resistance. And then three-phase supply will be given to the stator. Then the three-phase supply rotate a rotating magnetic field in the stator due to the currents flowing in the stator winding, and the speed of the stator magnetic field is synchronous speed, and that synchronous speed of field will also sweep over the conductors of the rotor here, and the conductors are a closed circuit via a rheostat. Here the higher resistance will be introduced at the beginning so that maximum torque will be induced or maximum torque will be produced by this rotor to the motor, so that the rotor or the motor will work like a induction motor, and that is rotor speed is slightly less than the synchronous speed. Synchronous speed means it is the speed of the stator magnetic field. Under this condition, this switch is connected to the DC supply so that the rotor poles are formed, and those number of poles will be equal to the stator poles, and because of the high magnetic polarity of these poles, this poles will lock with the stator magnetic poles to work like a synchronous motor. And coming to the advantages, because here the external resistance is connected with the rotor circuit, so it can provide the high starting torque and low starting current, which are desirable at the beginning. And now it works like a three-phase induction motor whose speed is slightly less than the synchronous speed. And this is used where high starting torque is required with less current. So let me summarize once again. So this synchronous motor will have the stator, and that is here it is star connected stator. A three-phase supply is given to this so that a rotating magnetic field is produced such that the number of poles on this stator are equal to the number of poles on the rotor, and the rotor initially connected to the three-phase rheostat with maximum resistance, so that maximum torque will be produced in this motor, and the rotor will rotate due to the current flowing in this at a speed slightly less than the synchronous speed. Under these conditions, this switch is disconnected from the three-phase rheostat but connected to the DC supply, so that the rotor poles will become strong, and these rotor poles will lock in with the stator magnetic field, so that the speed of the rotor and the speed of the rotating stator magnetic field will be one and the same. So that is, it works like a synchronous motor.